بكم في فيديو اليوم.
الدكتور ديفيد سينكلير هو عالم أسترالي مشهور في مجال العلوم الحيوية وعلم الأجيال. ولد في 26 نوفمبر 1969، وهو أستاذ جامعي وباحث في جامعة هارفارد بالولايات المتحدة الأمريكية. يعتبر الدكتور سينكلير من أبرز الخبراء في مجال الأبحاث حول آليات شيخوخة الخلايا والتأثيرات الجينية على عملية الشيخوخة وصحة الإنسان. واشتهر الدكتور ديفيد سينكلير بأبحاثه حول مادة النادرة نيكوتيناميد آدينين دينوكليوتيد (NAD) وتأثيرها على عملية الشيخوخة وصحة الجسم. قام بنشر العديد من الأبحاث والدراسات التي تساهم في فهم أفضل لكيفية تأثير هذه المادة على العمر والصحة البشرية. بشكل عام، يعتبر الدكتور ديفيد سينكلير من أبرز العلماء في مجال علم الأجيال والشيخوخة الخلوية، وبجهوده البحثية يسعى إلى تطوير أساليب وعلاجات تعزز من صحة الإنسان وتمنع تقدم عملية الشيخوخة.
أهلا بكم.
Welcome to the Lifespan Podcast, where we discuss the science of aging and how to be healthier at any stage of life. I'm David Sinclair. I'm a professor at Harvard Medical School who researches the biology of aging, and I'm co-director of the Center for the Biology of Aging. And I'm joined by my co-host and co-author, Matthew LaPlante.
Hey, we're back.
Hey, welcome. Good to see you again.
It's good to see you again, too.
This is episode 2. We're going to be covering when to eat and also what to eat within 24-hour periods as well as over a year. Not just to maximize your wellness and how you feel and look, but how to maximize your overall longevity. I'm going to talk about some of my protocols as well that I've developed over the last 20 years being a researcher in this area, and what works for me and what might work for you as well. If you missed episode 1, don't worry, we're going to cover the basics here, but you might want to go back and listen to episode 1 because we cover some of the fundamental biology that may help you understand what we're going to talk about today, even in more detail. So Matt, how have you been, man?
I'm good. Before we get started, we gotta thank the sponsors.
We do. Let's go straight into that.
Yeah.
It's important that we thank the sponsors because this podcast comes to you free. And we also get a chance to highlight some of the products that we love and have been using now for many years. Our first sponsor is Levels. Levels is an app that syncs with a continuous glucose monitor, which they provide, and interprets your glucose data for you. I've been so impressed by Levels that I've recently joined the company as an advisor. By monitoring your blood glucose, Levels allows you to see how different foods impact you. I've had fun running tests of my own, seeing how different foods impact my blood sugar levels. For example, I've learned that white rice and grapes really spike my blood sugar, whereas potatoes don't. As we've discussed on this podcast, having stable blood glucose is really important, not only for your daily mental and physical energy, but also for long-term health. If you would like to try Levels, you can skip the 150,000 people on the wait list and join them today by going to levels.link/Sinclair. That's levels.link/Sinclair. Today's podcast is also brought to us by Athletic Greens. Athletic Greens is an all-in-one daily greens drink that supports better health and peak performance. It's developed from a complex blend of 75 vitamins, minerals, and whole food-sourced ingredients. It's filled with adaptogens for recovery, probiotics, prebiotics, and digestive enzymes for gut health. They also have vitamin C and zinc citrate for immune support. I've been drinking Athletic Greens for a number of years now as a way to cover all my nutritional bases. I'm often traveling, and sometimes my diet just isn't the best. So by drinking Athletic Greens every morning, I know I'm getting all the vitamins and minerals that I need to stay healthy. If you'd like to try Athletic Greens, you should go to athleticgreens.com/Sinclair and you can claim a special offer. They're giving 5 free travel packs plus a year's supply of vitamin D3 and K2. Vitamin D3 is important for the immune system, and vitamin K2 is really important for keeping the calcium out of your arteries and putting it into your bones where it belongs. So again, go to athleticgreens.com/Sinclair and claim this special offer. Today's podcast is also brought to us by Inside Tracker. Inside Tracker is a personalized nutrition platform that analyzes data from your blood and your DNA to help you better understand your body and to reach your health goals. I've been using Inside Tracker for over a decade now, and I'm the chair of their scientific advisory board. The reason I've long used Inside Tracker is because they provide the best blood and DNA analysis that I'm aware of. that make it easy to get your blood drawn. You can either go to a local clinic or, like I do, have someone come to your home. It only takes 10 or 15 minutes. It's really easy. And from there, Inside Tracker presents your blood analysis in an easy to understand way. There are graphs and they give you diet and lifestyle recommendations that help you improve your blood biomarkers. Another feature that Inside Tracker has is their inner age test, which I helped develop. The test shows you what your biological age is, how it compares to your chronological age, and what you can do to improve that number. So if you'd like to try Inside Tracker, you should visit them at insidetracker.com/Sinclair, and you'll get 25% off any Inside Tracker plan. Use the code Sinclair, my last name, at the checkout.
Okay, so David, when we sat down together 3-4 years ago, we started mapping out this book, and I said, look, I need you to give me one starting place. When we're talking about health advice, like there's so much health information out there. I need you to give me one starting place. And you said immediately, you're like, I know, the one thing. So let's start there today because it relates to this episode. The one starting place
is, wait for it, drum roll.
For longevity, the one starting place is?
Eat less often. Those 3 words, eat less often. That is the one thing that will have the biggest impact on your longevity based on all the science we'll talk about today.
Okay. And this doesn't mean eat fewer calories necessarily. It can, and that's good.
Yes.
That's good. But a lot of people struggle to do that, to eat fewer calories.
Well, it comes naturally. If you're down to 1 meal a day, which I am now, you shed weight and then you get your 20-year-old body back. That's a nice bonus. But then you maintain that weight. You have a larger dinner, which is what I do to make sure I'm not becoming malnourished. Clearly, we're not talking about malnutrition or starvation here. It's about packing your calories into a shorter period of time.
That's because packing your meals into a shorter period almost inevitably means less calories, but that's not really what's happening here, right? It's not just about less calories. It's about what eating less often does inside of our bodies.
Right, and we'll get to that. But really, it's not just about the period of eating. It's the period of not eating that's so important for boosting the body's defenses against aging to maximize longevity. And we'll talk about how that actually works in a minute. But you can still have a large body and fast and get the benefits. In my lab, we've looked at mice that are obese and tricked them into thinking that they're fasted, and they live just as long as a skinny mouse. So really, it's about getting your body into this state of defense at any weight. Though I would say that there are certain optimal body weights that it's clear that if you're carrying excess weight, you're going to accelerate your aging clock.
What we don't want people to do is get the idea, though, that, oh, good, this works even if you're overweight, and so I can stay overweight, and then as long as I fast a little, it's going to be fine. That's not what you're saying also.
Right. There are certain body weights, waist to height ratios that are optimal for humans is about 0.5. But yeah, losing weight is helpful. We're not fat shaming anybody, but we're going through the science. This podcast is about what the science says, not what's socially acceptable. And it is true that if you're leaner, you will live longer. That is a fact. It's not necessary to get benefits by doing what we're going to say. But also, interestingly, as a side effect of eating less often, you will lose weight. I did. I've shed about 15 pounds since the beginning of the pandemic. And I look better, I feel better. And it's a nice side effect. But ultimately, what we're going to do here is we're going to say, these are the kind of things you should consider in your lifestyle. We're going to help you get there. We're going to ease you into it. There are some tricks that make it easier. And ultimately, you're going to end up with a lifestyle and hopefully a body that allows you to live decades longer.
We've made the promise on this program to really stick to the science, to let people know when the science is coming from studies involving animals, when the science is coming from studies involving human beings. The caveat here is really important. Most fasting research has been conducted so far on model organisms. But what we're seeing in those model organisms is fairly universal.
Well, it is. And the most reliable way to extend lifespan of any animal or even a yeast cell is to restrict its calories.
Well, let's start there because you started your career in yeast. You still study yeast. And one of the really big breakthroughs in understanding how to extend a yeast's lifespan came in your lab when you were studying what happens when yeast are calorie restricted.
Right. And that was the goal. The reason I went into aging research in part, and why I was so optimistic about being able to have a big impact, is that we know that restricting calories works on everything from a yeast to a spider, a fish, a worm, Labrador, pet Labradors. And it was 2002, there was a great study that showed you could lengthen lifespan of the Labradors from, 12 years to 14.
This is 1.8 years. And the only difference really was a 25% reduction in calories in that study.
That's remarkable. So I went to MIT in the 90s saying, I want to figure out how the heck this stuff works. How does this diet work? Because then we can bottle it. And we're basically at that point now. But to your point, just taking a pill isn't sufficient. If you add the pills plus the diet, you get an additive doubling effect. So we're going to go through supplements in another episode. Today, it's all about how to maximize when to eat and what to eat.
And that's really important because, look, not everybody can take supplements. Not everybody can access the supplements. We're going to talk about a lot of things, including things that you can do with, $10 in your pocket and things you can do and $100 in your pocket. But this is something you can do with whatever you're paying right now for food.
Well, it saves money, actually.
You can do it.
Yeah, you eat.
It doesn't say like you spend less on food.
Right. And the kinds of food we're going to recommend are fairly cheap foods. But getting back to yeast, I went to MIT to study this little fungus. It's a yeast cell you use to make bread and beer. It's microscopic. If you put 10 of them together, you might see them as a little dot. That's how small they are. But I used to love yeast. Literally, I would name them. They were little pets under the microscope. I'd follow them through their lifespan.
Adorable.
Yeah, I would get really sad when they would die after about a week because I got to know them. I would spend 14, actually more, probably 16 hours a day helping them along in their life, taking away their daughters, which is how we count. That
David, if you love something, you really shouldn't take its children away. That's pretty messed up.
That's true. If you leave the daughters, unfortunately, there's about 5 million of them by the end of the experiment, and you can't find the original mother. That's the reason.
Things they divide and they expand and they expand and they expand.
Exponentially, right. So you got to get rid of those daughters. You don't kill the daughters, you just move them away. But what we found was that when you reduce the amount of sugar in the plate, so they eat glucose, this is what we gave them, 2% glucose makes them live about 25 divisions, daughters. If you restrict that down to 0.5 glucose, so now down to 25% of that concentration, they will live over 30. And that's really cool, right? That you can just by changing the glucose levels, and we'll get to how that works in humans, very similar, you can extend lifespan. And what we showed was that there's a set of genes that controls that process. This isn't just glucose hurting the cell. There's a genetic pathway that gets triggered by low energy. And these genes we talked about in last episode, they're called sirtuins. And there are 5 of these genes in yeast and 7 in our bodies. And they respond to low energy. They respond to other stresses as well, such as high heat, low amino acids, high salt. The sirtuins will get activated by these, what we call hormetic effects. What doesn't kill them makes them stronger. And in this case, low energy led to the activation of these enzymes called sirtuins. And then they took care of the DNA repair and also stabilization of the epigenome. Now,
there's a lot there. We got to back. Let's slow this down and pace this out. Let's start with sirtuins. What's actually happening when, in the case of yeast or any organism in this case, because it's very similar mechanisms, right? What's actually happening with the sirtuins when yeast or any other model organism is calorie restricted, is fasted?
Yeah. Well, their role is to extend the lifespan. So what they're doing down at the very minute part of the cell is they're protecting DNA and making sure genes stay on when they should be on. But what's happening to boost their activity during caloric restriction, this low glucose level, we managed to figure out in the first couple of years when I moved my lab to Harvard Medical School, or started my lab at Harvard Medical School, we found that low energy activates a certain gene. It has a name. It's called PNC1. We have an equivalent gene in our bodies called NAMPT. And turning on that PNC1 gene in yeast was able to activate the sirtuins because that gene makes a fuel for the sirtuins called NAD. And so in our bodies as well, when we're hungry, these genes come on that make more NAD, this very small molecule that the sirtuins need for fuel. And then they do the protection. They repair DNA and they stabilize the epigenome.
And this is sort of the beginning place that led to NAD boosters, where we started going, oh, well, if we can boost NAD in other ways. And that's not, we'll talk about boosters in another episode, but just to sort of put that in the chronology of how this revelation came about and why so many people are now taking NR and NMN.
Yeah, that came out of our lab. We found two ways to activate the sirtuins synthetically. One was to use the red wine molecule, resveratrol, plus some other plant molecules that are now used in the supplement market. And that was a big craze in the 2000s from our lab. And then the second one, which is now probably an even bigger craze, is the NAD booster. And a lot of people are shooting themselves up with NAD or taking NAD precursor supplements. You mentioned NR and NMN. We'll get to those in another episode. But you can mimic low glucose in these yeast cells by giving them these NAD boosters. Or you can turn on this PNC1 gene artificially and they live longer in all cases. And we found that if we deleted that sirtuin gene in the yeast, either one of them or multiple ones, then caloric restriction in the yeast didn't work anymore, which told us that this wasn't just glucose being bad for you. Glucose doesn't hurt you. It's that the low glucose is activating the natural defense state of that cell, which we have inherited over the billions of years since we separated.
People are just going to cut out that little part where you just said glucose isn't bad for you, and they're just going to play that on a loop, and it's going to be great.
All right. Well, glucose is bad for you, but not for the reason that you might think.
So we have a little better understanding now of how sirtuins are turned on by fasting. We talked about two other classes of longevity genes in the first episode, mTOR and AMPK. Do you want to go really briefly through how these genes are impacted when we restrict calories, when we fast?
The first one is mTOR, which stands for mammalian target of rapamycin, the drug rapamycin. We talked a little bit about it in the last episode, but let's refresh everybody's memory. This is a protein complex in the cell that registers amino acids. When you have a lot of protein, you eat a big steak, it's going to activate this mTOR protein complex that causes the cell to build things. It's one of the reasons eating steak allows you to build more muscle, but that's not a recipe for longevity. What we know from many animal studies, even in yeast, if you downregulate the activity of this mTOR protein complex, you get longer life. Why? Because it's activating a process called autophagy, which recycles proteins. So when you're hungry, this autophagy will get all the old proteins, put them in the recycling bin, and then bring them out as fresh proteins. And that seems to be really important for longevity. In fact, even if you just inhibit mTOR and stimulate autophagy, that's sufficient to extend the lifespan of flies and even mice by dramatic amounts, even 30%.
So in mTOR, we start with fasting, we get longevity. In sirtuins, we start with fasting, we get longevity. In AMPK,
same thing. But in a different process. Exactly, it's doing something else.
Right.
And in this case, when you're hungry, AMPK will go up. AMPK, if you're wondering, it stands for AMP activated kinase, and that's just an enzyme that responds to low energy. So when you're hungry, you'll make more of it. And one of the main things that it does is it makes more mitochondria. We lose mitochondria as we get older, and when we exercise, we get more. And this is a way of artificially stimulating that production. Why do we need more mitochondria? Well, they're important for metabolizing things that you eat, but one of the main things that they are used for is to make energy, chemical energy. So when you activate AMPK, you'll feel better, you'll have more energy, and you'll also fight aging.
And you're using the word Yule a lot here. You're talking about presumably the people watching and listening to this are human beings. But we should note that, again, much of this research got done in model organisms. Human studies are a lot tougher.
But we have them for humans.
We do have them for human, but there are fewer of them, and they're most of the sample sizes are much smaller.
Yeah, but there's enough known about both mTOR and AMPK to make pretty strong conclusions that these are beneficial to human health as well. For example...
But this is, I guess what I'm getting at here, though, is the reason why. I think a lot of people would hear, well, there's all these animal studies, we're making all these conclusions on animal studies, and you don't have that many human studies. But human studies they take a really long time. They're really expensive.
Well, sure. And until this is 100% proven, many of us will be dead. So the point is, we're going to give people the information in this podcast, and in the notes, we're going to provide references. They can read more. to make informed decisions about whether they're going to try certain diets, lifestyles, and even medicines and supplements.
So what we know from studies of mTOR, AMPK, sirtuins, this tells our cells that times are tough. This triggers this metabolic shift into a different form of energy. And all of that, not all of that, but much of that we know from animal studies. As we mentioned before, the majority of the research on lifespan extension comes from model organisms, comes from animals that aren't us. But we're not just entering, we're in a world right now where we're doing this research on human beings as well.
We are. It's a fascinating time because we've got two worlds. And I walk in both worlds. One is there's clinical studies being done, some of which I'm involved in with NAD boosters at Harvard. We've been testing 2 years of those in humans, placebo-controlled, double-blind trial.
Like the gold standard stuff.
Right.
Yeah.
And those go to scientific publications. But because people can read the literature and hear about things, there's this self-experimentation world as well. A lot of it on the west coast of the USA. And you hear stuff, and these are anecdotal, but they also are interesting anecdotes that guide the clinical trials. And it's this very interesting time where we're in, where there are parts of the population, let's call it 1% of the US, that is not waiting for the proof that this works. But I do want to say before we move on that there is pretty good evidence that modulating these defenses in the body in humans also works and should extend longevity. We're not just blind and, I'm not crazy experimenting on myself and my father. What we know actually is that drugs that inhibit mTOR, rapamycin, in low dose, intermittent, does mimic fasting and does boost immunity and does give biochemical changes that mimic fasting and predict longevity. And there are people that are taking rapamycin. Again, we'll talk about that in episode 5. But there's also metformin, which is a diabetes drug, and that activates AMPK. And that's also, by looking at tens of thousands of people who take metformin for type 2 diabetes, been shown to slow down the occurrence, not just of diabetes, but other diseases of aging. Together, just those facts that I've told you make me convinced that fasting and the drugs that mimic fasting are going to be important for long-term health, but also wellness in your body today.
There's this other way of knowing, this other form of evidence for this that we haven't talked about yet that I think is important to bring up here. There's the double-blind, placebo-controlled studies that are ongoing right now that are showing, an impact in fasting on longevity. There's, like you say, the experimental, like really interesting, like, wow, that guy's looking really good and he's been fasting sort of thing, right?
Yeah.
But then there's these large populations and subgroups of populations all across the world who have fasted as a part of tradition and culture for hundreds, thousands of years. And there's pretty good evidence from these groups as well.
Right. Well, let's name some of them.
The Jains in India.
In India. They're probably the most well-studied group. And that there's scientific evidence that they have the most number of people over 70 in good health than any other religion.
Than any other group in India.
Yeah. Fair enough.
And a lot of people go, oh, well, the Jains are also vegetarian, but lots of people in India are vegetarian. And the Jains are even doing better than them.
Yes. And we'll get to the vegetarian diet and what the science says about that versus a meat-based diet. But there are other religions. Christians fast. There's Ramadan for Muslims. These are not just coincidences. These aren't just religious practices. It's clear that humanity has figured out that you feel better, you look better, you ultimately are disease resistant. You might even help cure diseases by going through these periods of being hungry or at least not having food in your tummy. Why? Because it activates these 3 longevity defenses that we just mentioned.
Now let's get into these really interesting, like sort of gold standard studies. There is one out of the Baylor College of Medicine. It was run by Isa Mendikoglu. This was published just last year, and it showed that fasting from dawn to sunset for 4 weeks improved blood pressure, reduced BMI, decreased waist circumference, and this is the important part, I mean, it's all important, but it upregulated DNA repair proteins. This is what we saw in all these model organisms as well.
Yeah, there are dozens of studies showing that periods of fasting is beneficial to people who are obese, not just because they lose weight, but they turn on their body's defenses. They become more insulin sensitive and their glucose levels come down. Also showing that people of regular weight, like me, can benefit from fasting. There's a number of studies there. And these are all in the show notes if somebody wants to go and check them out. But what's really interesting is that certain diseases, type 1 diabetes, multiple sclerosis, even cancer, those diseases seem to also benefit from fasting, including when you combine chemotherapy with fasting. You get this double benefit for many types of cancers. And then the final point that I think is really interesting is you can mimic fasting, say metformin. A number of doctors prescribe metformin to patients with prostate cancer because more studies are showing that these mimicries, these molecules that mimic fasting or combinations of both will help you beat cancer.
And to you, when you see a bunch of different disease states being affected, you don't think that what's happening is that each of these individual diseases is being played upon. You think that the thing upstream, the aging, is being affected, right?
Yeah, well, more specifically, those 3 defense components in the cell, they take care of the body, not just for aging, but to fight diseases. In young people, middle-aged, genetic diseases, even something you might not think of, like macular degeneration, has been shown to be slowed down and even reversed by fasting.
Okay, so far we've been really sort of broadly talking about fasting, calorie restriction, but we haven't sort of talked about like what that actually means. Let's talk about, because there's a lot, I mean, if somebody goes online right now, they're going to say like, how should I fast? They're going to get 1,000 different recommendations.
It's confusing for sure.
It's really confusing. Do we want to just talk about like what some of these fasting regimens are?
For sure. Let's do that. And we talked about them in our book, so that's also a resource. I get questions every day from people, how should I fast? And my first answer is, well, you're an individual. You've got a different lifestyle, different tolerance for pain and hunger. You're a female or a male. You've got different microbiome. These are really important things to take into consideration. When we recommend things, what we're saying is you can try this. If it doesn't work for you, try something else. But also, just to talk about one of our sponsors, Inside Tracker, I use Inside Tracker because it's not just, oh, I feel better today. We actually have to measure things, get a dashboard on your body to know if the what you're doing, whether it's exercise or in this case, your diet and when you eat, is working for you. And that's why I've been able to optimize my diet over the last 20, in fact, 30 years. I'm not just guessing, I'm actually measuring it. Yeah.
You're measuring. It's a little insane that the way that we sort of like went about testing out whether or not these different eating regimens were working for us is like, do I feel better? Do I not feel better? It's so vague. It's really nebulous.
Yeah. Well, you wouldn't drive a car without a dashboard. So why do we do that for our bodies, which are even more important?
Yeah, bad habits.
Yeah.
That's what we do, right? That's what we've always done. I feel good. I don't feel good.
Yeah. Well, this is why I have autopilot. I drive a little crazy. I do that with my body as well. It's all an experiment. But let's go through the diets. Okay, so there's a fasting mimicking diet. Volta Longo, a colleague of mine from UCLA, is a proponent of that. That's a diet that lowers mTOR activity. It's low in these branched chain amino acids that I've mentioned.
Okay, and is that a diet that mimics fasting, or does that include periods of actually not taking in any calories?
It's both, but you don't have to be as rigorous about the period. The food itself will mimic it.
So the food itself is being processed by your body in such a way that the body is like, I could really use a little bit more. Or I could really like a little bit more.
Yeah,
that.
You want the body to be in a state of perceived adversity. Mm-hmm. Oh my goodness, I'm running out of food. I'm not eating meat anymore because plants have less of these amino acids. So it responds to that low amino acid input. Volta's done some great work. Over the last few years, he and his group have shown that on this fasting mimicking diet, which they can send to your home, that actually helps cancer patients survive and get over chemotherapy quicker. Again, more evidence that fasting is good, not just for longevity, but for diseases. So that's one. The next one, let's talk about, which a lot of people call intermittent fasting. We'll just call it fasting. This is a period if you go longer than a day. Some people do 3 days. Some people go for a week. I wouldn't go longer than that because then you'll start chewing up your muscle, which you don't want to do. But these long extended periods are doing a real deep cleanse on the body and turning on that autophagy, that process of recycling proteins very deeply, especially once you get beyond the 3-day mark, when your metabolism switches into what's called chaperone-mediated autophagy, the deep cleanse. So that's fasting. And then there's time-restricted feeding, which is what I do, because I'm not very good at going beyond 24 hours.
Well, I think most people would really, really struggle to get there.
Yeah, time-restricted feeding, which is what I do, which is try not to eat till dinner. That's hard enough. My hat's off to people like Peter Attia, the doctor and podcaster, who many of our audience will have heard of. He can go for a week, and he's got a lot of willpower. If you've ever met the guy, he's different than me. I'm more of a hedonist, but
Is he grumpier at the end of the week, do you think, than he is at the beginning of the week, though? I mean, like after all of that time?
He's always serious. That's what I can tell you, but brilliant. But let's get back to this time-restricted feeding. You want to have at least 16 hours of not eating or not eating very much. And then you can have 8 hours. So typically that means having a late lunch if you skip breakfast. Or if you prefer to skip dinner, skip that.
Because what we got to remember here is that there's a period of sleep in which you are not eating. And
That's
so
the easy part.
What
Yeah.
you're really doing is tacking on hours to the front of that and tacking on hours to the back of that.
That's right. So when people say I'm skipping lunch, that's not as helpful. And so what I've done in my life, let's just use me as an example of an average human being, because I'm pretty lazy and I'm not that driven. I prefer to take a pill, which is not the right thing. What I started out in my life was not to eat breakfast, and I've pretty much been doing that since I was a teenager. And that for me works because I'm not really hungry in the morning. I have a cup of tea or a cup of coffee, and I still do that. A little bit of yogurt to mix my supplements with to dissolve them, but that's
and you're not doing the yogurt. And I've actually seen you do this. That like the amount of yogurt that you put into your little bowl is really minimal. It's basically just to mix up
a couple of spoons.
Yeah,
that's it, and that's burnt off in 15 minutes. That's not going to be a big deal for the rest of the day. And I try not to eat at all until dinner, and then I have a really enjoyable, large-ish dinner. But it's certain type of food. We'll talk about the types of food later. But that gives my body this long window, more than 20 hours of not having glucose circulating from the external world. Now, what happens when you do that, and it takes a few weeks for your body to adapt, is that your liver will learn how to compensate for a lack of food. It's called gluconeogenesis, the generation of glucose from your liver, and it actually overcomes the feeling of hunger. When you first skip breakfast and lunch, you're going to be hungry. You're going to be nervous. You're going to say, I can't do this. Sinclair is an idiot.
Well, this is why people fail at this, is because they run into that and they think, this is how life is going to be for the rest of the time that I'm on this diet. I can't do this diet.
Right. But do it for at least 2 weeks, because after the 2 week, especially by the 3 week mark, your liver has now learned that you're not going to have breakfast or lunch, and it will start making glucose at a steady level. That's really important because it's known that if you have these spikes of glucose, it leads to hunger when it crashes after a big meal, but also that when you get hungry, you eat. So you're in this wave of hunger, eating, wave of hunger and eating.
Do you think people should ramp up? I mean, you just said like do no breakfast and lunch for 2 weeks, but should they ramp up by like breakfast first and let their liver get used to compensating for no breakfast and then add lunch?
Well, I would skip one meal and then go for two.
Yeah.
You can't do the whole thing. Most people will fail. But you're trying to avoid this thing I was just talking about called reactive hypoglycemia, is that if you eat a piece of toast for breakfast or heaven forbid, a giant glass of orange juice, you'll have this spike in sugar and you'll feel great. But then your body will put out too much insulin and suck that glucose out of your bloodstream and put you into a glucose deficit. And that's hypoglycemia. And then you're hungry. You've got ghrelin coming out into your body and you feel hungry and you need to eat something. I'm at a state, though, now where I don't get those rises and crashes. My liver is putting out glucose from when I wake up till dinner. And I've never been so focused. I've never been so brain fog free. Because these crashes, what they do is they make you feel shaky or tired and brain fog. And I wish I'd done this in my 20s and done it my whole life, because I've really never felt better because of it.
We can actually measure this now with continual glucose monitors.
Right. And this is a shameless plug to our one of our sponsors.
I was not intentionally creating this moment for a shameless plug, but we can.
Yeah, well, let's mention them because it makes this podcast free. So Levels provides glucose monitors that you stick them on your arm and they measure the glucose levels. And I've used one of them. And what I found was that there are certain foods that spike my sugar really high and then I get the crash. And it's very clear that when I'm feeling jittery and hungry, I am in that hypoglycemic state that comes after a big meal or even a piece of toast for me or a bagel. That's really important because then you'll learn what your microbiome in your body responds to well and not. For me, I was surprised that white rice, toast, grapes were really bad and potatoes weren't that bad. And so now I've optimized my diet to not have these periods even after dinner where I feel crappy.
And not everybody's going to respond the same way. Like you said earlier, we all have different lifestyles. We've got different genes. Jim Nelson's work's been sort of informative in this.
Yeah, so Jim did an important study in mice, again, not humans, but it tells us that genetics is important because he took very similar mouse strains of some called black 6 and then some white ones, and he crossed them together to make of genetic diversity a colony of about 100 different types of mice and put them on the standard caloric restriction protocol, which by recollection it was close to 35% of what a mouse would eat given food all the time, ad libitum we call it. And about half the strains of mice lived longer, and then about a third of what the remaining ones lived shorter. And that was a shock because we thought caloric restriction always works. That's not true. It can depend on your genetics. And we've now learned that some strains of mice, and probably humans as well, are much more sensitive to this diet, these types of diets, and you probably want to do it a little less than someone else. And you only know that if you try it on yourself and measure things.
I like this idea that we're all just sort of lab rats running around trying things out right now.
Well, I get criticized by some doctors advocating that. You're not supposed to be experimenting on yourself. Even people say you shouldn't be allowed to have continuous glucose monitors. How dare you measure your body? And my view on that is, well, we should ban bathroom scales if we're not allowed to measure our body.
Well, I love the fact that you're doing this because I'm going to let you do it ahead of me, and then I'm just going to wait and see what really works and what doesn't really work, and that becomes a starting point. But that is sort of like what you've been doing. I mean, what you've been doing for a really long time, and you've been pretty open with people about like, here's what I'm doing and here's what I'm doing right now. And it hasn't been consistent for 20 or 30 years. Yeah. Sometimes you start and stop things too because it's working and it stops working, or it feels like it might be a good idea and it doesn't. That's what we're all doing.
Well, I've made plenty of mistakes. I don't talk about my mistakes as much as I should probably, but I've had times where I ate the wrong things and ate too much and gained weight, and my inside tracker results were horrendous.
Did you ever make any mistakes in fasting? Like when it comes to fasting itself, because you've tried different kinds of fasts. Which one really, really didn't work for you?
Well, they were all beneficial. Skipping the breakfast was good. I think what got me into trouble was when I tried to do it without preparation. So I said, okay, I'm going to just skip lunch and go to dinner without knowing how to do that or being in the right mindset. And I had to quit multiple times. I spent years trying to do this. I could never get rid of my love handles. And this final time that worked for me worked because I found a trick. And that trick, I'm not going to tell you. I'll tell you.
No, you have to.
The trick is that you want to fill your body with fluids. For me, constant coffee, tea, hot water, all the way through the day, being hydrated and filled with liquid takes away any feeling of hunger. Also nuts. If you really you need to eat something, a bit of protein is known to take away the feeling of hunger rapidly.
Yeah, this is what my buddy, the cardiologist, John Day, tells his patients when he's working with them is like, look, if you got to eat, just start with a handful of nuts and just give me 20 minutes after that. You're not going to be hungry after 20 minutes.
So there's an interesting story about the role of protein in hunger, and it was first discovered by a friend of mine, Stephen Simpson, in Australia, and he was studying locusts, and he found out that what turns a locust into a swarm was a lack of protein. And when they get too low in protein, they go crazy.
The locusts get hangry.
And they start eating each other. It's that bad.
Yeah, and everything else in their sight.
Yeah, and we even see this in the mice that we have on low-protein diets. They get super mad and they even attack each other. So you don't want to be too low in anything. You don't want to be hangry. But getting back to what really works for me is I've trained my liver to produce enough sugar that I don't feel hungry anymore. And if I do, I'll keep drinking liquids. And if I get really hungry, I'll nibble on some nuts. And that, for me, has worked really well. I've got my 20-year-old body back for the first time in my life. And
But you are going to be
go
hungry.
back.
Anybody who starts this, they're going to be hungry at first.
Of course.
They're going to be hungry
It's
at
not
first.
easy. I'm not saying that it's going to be easy, but it's worth it.
And there's an important point to make here, and we sort of touched on it at the beginning, but I think we need to circle back to it because it's so important, because we're not talking about starvation. We're talking about intermittent fasting with adequate nutrition. That adequate part's really important.
Yeah, so the acronym would be IFAN. All right, trademark that one. IFAN, let's call it the new type of dieting. By the way, intermittent fasting, I learned about a month ago, is the most popular diet in the US. We talk about it in the book. That might be part of it. But yeah, it's important that we add the AN at the end, because we need the adequate nutrition. And there's one sponsor we haven't mentioned, which is Athletic Greens.
Jesus.
But this is true. The reason that I drink Athletic Greens.
You're really good at working these in.
Well, they're important to us. But the important part is that the adequate nutrition is necessary. Otherwise, you're going to be causing more harm than good. So when I take Athletic Greens, I drink it in the morning, I know I'm getting all those nutrients that I might not get during the day.
So now that we sort of set the stage for when we eat, which is really important, when we eat, we still have to acknowledge we have to eat sometimes. Somebody's going to, sometimes you're going to, if you intermittently fast, if you're going, 20 hours without food, you're going to have breakfast or you're going to have dinner. So yeah, there's going to be something on your plate. It's really important also what's actually on your plate. And that's what this next half of this episode is about, is what we should eat when we are eating. And maybe the best way to start this really, though, is to talk about what definitely shouldn't be, or not definitely shouldn't. There should be a lot less of on that plate.
Right. Well, the big killer is sugar. Glucose, particularly fructose, is also pernicious. And if you give animals lots of glucose, and especially fructose, they will get fatty liver disease, they'll get diabetes. It's really bad.
And this one is absolutely not controversial, right? Like, we're going to talk about meat later and people are going to be really up in arms. But if you say the big killer is sugar, there's not a group of people that's going to come hunt us down. Sugar is bad.
It is. And
why?
Well, why? Well, there are two reasons that glucose is bad when it spikes. Three if you include the brain fog, but let's just talk about physiology here. One is that you're going to have glucose attached to proteins that makes them glom up. Think of it like caramelized body parts. This will ultimately lower your longevity, reduce your longevity, give you type 2 diabetes and probably cardiovascular disease on top of that. So that's one, keep those glucose levels down. But also what glucose is going to be doing to you at high levels is shutting off those protective mechanisms. Remember, particularly AMPK and the sirtuins, they get switched off by sugar. So by having that up for most of the day, if you're eating 3 meals plus snacks, your defenses against disease and aging are going to be working at a minimum. So instead, keep those glucose levels low and consistent. You won't get the brain fog. You'll get fewer proteins modified that'll lead to disease. And thirdly, importantly, you'll actually stimulate your body's natural defenses against disease and aging.
So sort of like the first step, sugars. Let's get rid of the sugars.
Yeah, on that note, by the way, I gave up dessert at age 40, though occasionally I steal it, and it doesn't count if you steal it, right?
No, I think there's a special little pocket it goes into that doesn't count against
it's invisible.
Any of your, right. Inside Tracker doesn't pick it up.
Right. Well, here's the point. You can quit something, but you don't have to be draconian about it. I still like to steal a few scoops of ice cream if I see it, but I'm not going to eat a giant bowl of ice cream every night. That's a quick way to shorter lifespan.
We're not trying to ruin everybody's joy.
No, not at all. Often when I give talks at dinners, people skip dessert after I've spoken. I feel bad about that.
Well, you remember we were talking about doing an experiment where we would have a conversation around a table with people and then have the servers come with a birthday cake or something and just watch them.
We still should do that. But yeah, so glucose is a bad one. Something else to avoid is super high protein because mTOR, it can be activated, but you don't want it activated all the time because it's not going to turn on the autophagy, the defenses to recycle proteins.
And this one is going to piss a lot of people off.
Well, yeah, I mean, there's a lot of people who believe that carnivore diets are the best for longevity.
And for some people, a lot of aminos are appropriate.
Well, certainly if you're an athlete, or you want to bulk up, there are short-term gains. You'll feel better if you eat meat. You'll obviously have the protein to build up that muscle. But we can go through the evidence. When you look at populations of what they eat and how long they live, as well as the short-term effects when you eat a high-protein, carnivorous, red meat-based diet, those changes will be good in the short run. But long-term, there's no evidence. In fact, I would say there's counter-evidence to that being beneficial for longevity if that's your goal.
And that's because of the inhibition of TOR.
In large part, yes. The sirtuins will also get switched off by high protein as well.
So aminos are important. We have to have them. If we don't have them, we die. But you can get aminos from plants as well as from animals.
Yeah, it's funny when I say I've gone vegetarian recently, which is a fact.
Where are you going to get your protein?
Yeah, where do you get protein from? Well, what do you think a plant's made of? It's also mostly protein. Now, they're not as bioavailable, so you're getting like 2/3 the amount as you would from a steak.
Your body has to work a little harder for it.
Great.
Yeah.
I want my body to work harder. It's good for it. It burns energy. It's also activating these defenses, as we mentioned. So I'm now trying out this a full vegetarian diet. I'm not yet vegan, but that actually probably works even better for longevity, as the science will tell.
How's it working for you? You feeling? Do you miss meat?
I do. I love meat. I think meat tastes great, but I'm more and more inclined to enjoy vegetable as well.
So we're starting to go down and talk about vegetarian diets, plant-based diets here. We're gonna talk about a lot of those different choices in a minute here, but I do want to take us back for just a second to what's happening, like really what's actually happening inside our bodies when I sit down, and I still eat meat. I haven't followed you down this path yet. I love a steak. When I put a steak on my plate and I eat it, what's happening? What are those aminos doing?
Well, before you get aminos out of meat, you need to digest it. And so the first step is acid in your stomach is going to break down that meat into amino acids. And then your microbiomes can utilize a lot of them. And then those amino acids are also going to leach into your bloodstream. So now you've got these amino acids circling in your body, circulating. And there are 3 ones that are particularly important to know about. It's leucine, isoleucine, and valine, also known as the branched chain amino acids. And these are used by the body to sense protein intake. And the sensor is this protein complex we talked about called mTOR. Mm-hmm. And when there's lots of these 3 branched chain amino acids, particularly leucine, it'll be activated. And this mTOR, the role is to say, wow, we've got lots of amino acids, let's build muscle, let's repair cells, let's do all good stuff, which is why you feel good if you eat red meat and your microbiome can handle it.
Yeah, I feel great. I feel like I can fight a lion.
Yeah, you might have to fight a lion to get it. But what actually is going on that's deleterious is, in the long run, is that mTOR can do something even better for your longevity than build new muscle. It actually can turn on this recycling program called autophagy. And that it's very clear. There's no debate as to whether autophagy is good for you or bad for you. It's definitely good. So what I think people could do is to, if they want to eat meat, go for it. But try to focus on plant-based food more often so that there are periods during the week when there aren't as many leucine, isoleucine, valine molecules floating around in your body so that you have a chance for your mTOR downregulation to recycle proteins. Now, why do you want to recycle proteins? You might say, well, who cares about recycling proteins? Well, Alzheimer's disease is a good example of proteins that get modified and accumulate in your brain. And it happens not just in the brain, but in all tissues. We have these old proteins that linger, cause us to get old, to malfunction. But it's reversible. And it's reversible by fasting. It's reversible also by having low levels of these branched chain amino acids, at least part of the week.
Let's talk about these primarily plant-based diets. There is vegan diets out there. You said probably that's for many people, that's probably going to be the gold standard. But a lot of these plant-based diets have a little bit of meat in them. There's the Mediterranean diet. There's the Okinawan diet.
Lacto-ovo-vegetarianism.
Right, lacto-ovo-vegetarian diet. Is there anything you want to say about these, or can we talk about them as sort of an umbrella group? Do we call them blue zone diets?
Well, let's talk about blue zones in a minute. I think what's interesting is that there was a really big study by the Adventist Health Group, 2013.
Yeah.
Let's talk about that, because what they calculated was the chance of dying based on various diets. And these were thousands of people. And what they found was that what's called the hazard ratio went down the more vegetarian and vegan you were. What does that mean? Your chance of dying goes down. And the number goes from 0 to 1. Whereas 1 is you're pretty likely to die tomorrow. Whereas a low number, which is around 80, means you've got 20% less chance of dying on any given day with this hazard ratio. So the numbers are the following. Non-vegetarians are at 1, if you call that 1. Compared to that, the next best one was semi-vegetarians at 0.92, and octo-ovo or lacto-ovo vegetarians 0.91. Okay, so about almost a 10% reduction in mortality, death. And then you get into vegans, which 0.85, so it's 15% reduction in death. And then the best one was pesco vegetarians, so getting a little bit of meat.
A little bit of fish.
Yeah, a little bit of meat from fish. Probably the fish oils in there are beneficial. And then you're down to 0.81, so that's a 19% reduction in your chance of death at any given day late in life.
Okay, now that's all cause mortality, but we can also now see this in biologic aging because we now have clocks that we can use to measure our biological age. And there are studies now also that are showing that these diets are effectively reducing biological aging as well.
Right, and there are a couple of these. There's a 1-year study looking at a diet of mostly vegetarian. But the one that I think is really exciting is one that just came out a couple of months ago that looked at mostly women on a Mediterranean diet plus exercise over 2 years. And they could now calculate what happens to your biological age over those 2 years, having switched the diet. And they had various recommendations. It's very typical Mediterranean. Limit alcohol. If you have red wine, that's fine. A little bit of fish. Only use olive oil as your fat. And focus mostly on plants. That was their lifestyle. And then exercise was walking and some other weightlifting.
That's the Fiorito study?
Yeah.
Okay, so the interesting thing about this study, at least to me, the thing that jumped out at me is it came out of Giovanna Masala's lab at the Cancer Institute in Italy. And like you go like, well, why do people whose primary responsibility is to study cancer care about aging? And it comes back to this thing that you've been saying all along, which is that if we can reduce people's biological aging, we can cut diseases off where they actually start.
Well, that's exactly right. That these diseases that we think are just diseases are mostly caused by aging itself, and that slowing down that clock by fasting or eating the right foods, Mediterranean diet, is now shown not just to slow down the ticking of the clock, but probably reverses your age as well. And that's a mind-blowing concept. You have to think about that for a minute, that it's possible by changing your diet to reverse your biological age.
One of the diets that stands to do this well, likely, that I know you're a big fan of is the Okinawan diet. You were on the Okinawan diet for quite some time, right?
Yeah, I was. The Wilcox brothers wrote a book in the 2000s that I loved. And it's mostly carbohydrate, so there's a fair amount of rice, but probably could have done better with a bit of brown rice. White rice sends your glucose through the roof.
Right.
But mostly what I was eating were Chinese or Japanese vegetables that I could get at the local market. So they're organic, fresh, green, full of vitamins, and soy. Mostly it was that. It was a plant-based, soy-based diet with a little bit of fish. And I looked great. I felt great. And then my kids came along and we ate pizza for a few years. But it was great while it lasted. And if you look at the Okinawans on the island of Japan, they are arguably the longest lived people on the planet. But they have other things that are good for them, things like social structure and exercise. They work until they're in their 90s or 100.
None of these things happen in a void.
Right. But that lifestyle is probably the ultimate for human longevity. And we know this because if Okinawans moved to, say, Hawaii, which a lot of Japanese did, then they don't live long anymore.
Mm-hmm. Yeah. You talked about lifestyle. This is a really big part of, you said you wanted to get back to the Blue Zones idea. You go across the world, you look at these communities of long-lived people. They have a lot of things in common. And we've been talking about diet today, so let's just jump into that. And there's been criticism of Blue Zones too.
Yeah, so Dr. Harriet Hall has said that those demographic data, people's ages weren't actually correct. But if you dig into it, they did a really good job. So Dan Buettner, I think, is right in saying that these people tend to live a long time. Out of hundreds of people that they checked the records of going back in the city records, there was one person that was misjudged. What was it? That
they thought they were like 111 and they were actually 107 or something.
Yeah, big deal. Okay, but that, of course, all studies have caveats. But this, I think, is really clear that areas of the world that have the right combination of foods, exercise, social structure, they do live longer. This is no surprise. Even in yeast, when we don't give them social life, but when we modify their diet or give them food in a time-restricted fashion, they also live longer. So I don't understand why it's controversial.
There's one more idea about how we should eat that I know you're a big fan of. There's less research behind it, but you believe pretty strongly, I'd say. And there is evidence, but I think it's still emerging and there needs to be more research. But this idea of xenohormesis, this idea of eating plants that have, not just eating a plant-based diet, but specifically focusing on plants that have experienced stress. Talk about that and why you are so focused on this idea.
Well, the xenohormesis concept, Conrad Howitz and I coined this term in the mid-2000s, trying to explain why so many plant molecules are good for us. It just cannot be a coincidence. And we came up with this idea really prompted by a 2003 Nature paper that we co-published that found that there were at least 20 plant molecules called polyphenols that activate the sirtuin enzyme called SIRT1, the number one out of the 7 family members. And when I looked into it, these polyphenols do remarkable things to the body. The one that got the most media attention because it's in red wine is resveratrol, but there's picetanol and there's fisetin and quercetin. These are supplements that people are getting excited about only now. But when you look into it, they activate and inhibit pathways or proteins in the body that are known to be important for health and longevity. And in some cases, the same molecule will inhibit one protein and activate another one in just the right way to promote health. That cannot be a coincidence. There's no way that could just happen randomly. So the idea is that we've evolved mechanisms to sense when our food supply, the plants that we eat, are stressed.
Because it's like an early warning system?
Right. You know, we're humans. We can see that the plants are wilting and we know that the crops are dehydrated. We can measure the soil. Most organisms on the planet don't even have eyes. How would they know if their food supply is going to run out unless they sensed the stress, the fear in those foodstuffs? And so when you stress a plant, you get more resveratrol, you get more quercetin, picetanol. And if you look at...
What kind of plants, we should say? I mean, it's not every plant that we're going to get those things in.
Of course, it's every plant.
Is every plant
Well,
that
plants
gets
have sirtuin genes, and they need to survive just like we do. Mm-hmm. And they make these polyphenols in order to survive when they run out of, or running out of water and nutrients.
Okay, where are we going to get them most, though?
Or even preyed upon by caterpillars.
Yeah.
But in our food supply, a lot of plants have very few of these molecules. Why? Because we think that the faster they grow and the less stress that they have, the better. It's actually more profitable for a farmer to grow plants that grow really quickly and have no stress. But are they better for us? Absolutely not. So how do we know if a food has been stressed? Well, you can start with the generalization that if they're grown out in a field organically without pesticides, probably they're more stressed, right? But also there are foods that are intentionally stressed. Red wine is one. The best red wines are ones where the vines are dehydrated or have fungus growing on them. There's a good reason for that. We know that they taste better. Why? Because xenohermetic molecules are made along with molecules that taste good and are filled with color. It's the plant defenses. And so what I look for are plants that are organic, local, and colorful, because those are the ones that are most likely to have those molecules. In the case of red wine, choose grape varieties that are stress sensitive. Pinot Noir is one of the most sensitive, if not the most sensitive grape variety. And that's why it has the most resveratrol of any other type of wine.
Let's bring this all together now. There's a lot of information here, but there's sort of a checklist. And so let's talk about, like, if people got to have like 4 takeaways here, 5 takeaways. Eat less often. You would say start with eating less often by skipping one meal a day and moving from there.
Yeah. And don't snack.
And don't snack.
Yep. Avoid sugary drinks and foods.
Okay. Eat less often. When you do eat, kill the sugar.
Yeah. I try to eat artificial sweeteners and natural ones. So stevia is a big one for me. And there are some others that are out on the market that are naturally occurring sweeteners.
Okay. Start working toward reducing your meat intake. If you're dieting, if your diet is aimed at longevity, very likely you're going to need to drop your meat intake.
Yeah, it causes a lot of concern of people who are pro meat, but the data is the data, and we've got these references in our show notes that reducing the amount of red meat and in particular processed meats is beneficial for long-term health and even prevention of cancer. One of the things that's not appreciated about red meat, I'll just mention this, is that it's not just that they have more of these 3 branched-chain amino acids that prevents mTOR from doing its good stuff to the body. There's also a molecule called TMA that is in the meat that goes into the bloodstream. The liver turns it into a toxic molecule called TMAO. And this TMAO is shown, at least in animals, probably in people, to accelerate cardiovascular disease.
Right.
So I would say...
Cancer too, right?
Yeah. And so what we want to do is to limit the nitrates, the preserved meats. If you like a good steak, by all means, eat one. It's not going to kill you. But if you try to just push yourselves towards a more plant-based, plant-focused diet and maybe have some red wine occasionally, a lot of olive oil with oleic acid, which activates sirtuins as well. The Mediterranean diet is the one that I think is likely to be the easiest to do in the Western world and to have the biggest bang for the buck. You can go a little bit further, like I have. Don't eat meat, and eventually maybe I'll give up everything that's dairy and eggs. But the Mediterranean diet is a very enjoyable diet. I lived on it for over a decade. And one of the things that's not well known is that there are studies of Mediterranean diet versus Western diet. And it's a massive difference. There's one here that was published in just 2000. There was a reduction in mortality.
In 2000 or?
In 2000, the year 2000.
So it's 20-something years ago.
It's 20-something years ago, but there are a lot of studies since. There's at least 5 studies that have backed this up. If you switch to a Mediterranean diet, if you're under 80 and you do that, you reduce your mortality, chances of death on any given day by 31%.
I like if you're under 80, which means you can still take advantage of this even if you're way deep into your life.
Right. And I would say probably in this study, they just didn't include people over 80. So I don't know for a fact that it wouldn't work on 80-year-olds at this point.
Right.
But yeah, that's the point that's really important. Often when I give talks to crowds, they are elderly. And often the question comes up, is it too late for me? The answer is it's never too late. Dietary changes in older people can have massive benefits. Some people say, you need to carry a bit of fat on people that, if you're over 80, you should have a little bit of body fat.
There was a study that a lot of people latched on to that they got really excited about because it was like, if you're older, you can be fat.
Yeah. Well, it turns out that's not true. When those studies have been redone, being lean as an older person is also beneficial. If you go to a nursing home, I don't know how many people listening have been to a nursing home, but when you go there, look around. Who's alive? They're not giant men who are obese. They're little women who are skinny. There's an experiment right there. It's obvious, right in plain sight.
Okay, so eat less, start working toward fasting, cut the sugar, cut the meat, eat the veggies. Don't cut the meat and respond with like a bunch of carbohydrates. Eat the veggies. And if you are going to eat the veggies and you can find ones that have been stressed out and are enjoying a little xenohormetic, you may enjoy a little xenohormetic effect from that.
That's great. And there's even an order at which you can eat your meals to reduce the blood sugar spike. You can put the sugar at the end of the meal. So dessert is fine but put it at the end. Don't start with sugar. Don't start with the carbohydrate because that will immediately spike your glucose.
So if you are going to go back to that like second and third point, if you are going to eat sugar, eat it at the end of the meal.
Right. What you eat during the meal and in which order it also makes a difference.
And
Start with the
don't
protein
snack on
and the
sugar
fat.
during the day. That's just
Oh my goodness. Eating candy during the day is just going to make you feel lethargic when that sugar goes away.
Well, we're doing this really horrible thing to children by, telling them that their lives are, like the sugar is this really great thing that they should have all the time. They should be able to have snacks that are laden with sugar and start breakfast that starts with sugar. And
yeah, well, I blame the food industry for that because they want to sell more food. And we've been taught that children should never go hungry. Breakfast is the best meal of the day. And we've got an obesity epidemic in kids, no surprise. And what parent doesn't feel guilty when their kid feels hunger? But for long-term health, even programming the epigenome for long-term health requires some hunger in individuals. And what we do to kids is we say, big breakfast, here's a snack, here's a lunch, terrible lunch typically at schools, public schools, big dinner, go to bed full, wake up, eat some more. We're not just causing problems for these kids' physiology for the long run, 20, 30 years later, because their epigenome is now set for feast, not famine.
right.
But we're also setting them up for obesity, which shuts off their survival programs right now. So their bodies are aging quicker than they otherwise would.
I wonder if that's not a really important sort of frame to put what we call the obesity epidemic into. Is it's not just an epidemic of making people bigger, it's an epidemic of making people age faster.
Absolutely. And we're going to see the impact of this in 2 or 3 decades from now with an increase of these diseases because the clock has been accelerated.
So this is, most of our listeners, most of the people who are listening to this, watching this, are going to be adults, are going to be making decisions for themselves. But much of this, if not all of this, is really translatable to what parents should be starting to help their children develop the habits of eating in these patterns as well.
Right. And
part of that
okay
is
to
getting
feel
used
hungry.
to being hungry once
Exactly.
in a while.
Yeah. And not just have food lying around that whenever they want a snack, they can. That is the way that we evolved. We have this metabolic winter hypothesis that we've published. When we were, going back probably 100,000 years ago, back to 6 million, what was our lifestyle? We were cold and hungry. These days we live in air-conditioned and heated houses with food always available, which goes against what we've evolved to be optimal. And so we've got to go back to those days where occasionally we were hungry, occasionally we were cold. We'll get to cold therapy later. But basically the concept, if there's nothing else that you remember about this topic, just remember this, that we need to put our bodies in a state of want for them to fight diseases and have ultimate health in old age and give us longevity.
That's a really good place, I think, to stop for now, because the next thing we're going to talk about is other ways to put our bodies into states of stress. That's episode 3. Do you want to preview that just a little bit?
Well, there are certain things you can do. We're going to talk about exercise and cold therapy and so on, as these are ways of making the body feel like it's in a state of adversity.
And do very much what fasting and these diets do, which is activate these longevity genes.
That's exactly it. And the exciting part about the world we live in now is we're learning what is the best combo of those things. And we'll talk about that in next week's episode. Thank you for joining us today. If you're enjoying this podcast and would like to support us, please subscribe on YouTube, on Apple Podcasts, and on Spotify. On Apple Podcasts, you have the opportunity to leave us up to a 5-star review. Also, please support the sponsors we mentioned at the beginning of the episode. That's probably the best way to help us. We also have a Patreon account. It's patreon.com/David Sinclair. There you can support us at any level you like. Thank you for joining us, and we'll be back next week to discuss exercise, cold exposure, heat exposure, and other acute stresses.